Very good evening to one and all gathered here. So in today's lecture session, we are going to see about line balancing concept in operation and production management. And this is my today's agenda for a technical presentation on line balancing concept. So first let us understand what do you mean by line balancing problem. What are the various technical objectives of line balancing and typical steps carried out in line balancing problem and different techniques used in line balancing. And finally, a closing remark for the technical idea on line balancing concept. So we will start with the basic introduction. What is meant by line balancing? So line balancing is a production strategy which helps to optimize the different assignment of operator to various workstations within an assembly line system in order to reduce the idle time in every workstation. At the same time, controlling the minimum number of workstations to be used in the assembly line. So we want to balance the idle time at the same time, number of workstation utilized in assembly line that should also be productive in nature. So every workstation should be equally balanced in nature, in such a way that none of the assembly line should not be kept idle forever. In this way, we can able to improve the line productiveness efficiency. The further continuation given in the next slide, the line balancing tries to reduce the fluctuation within a production line. The balanced assembly line is said to be stable if it is capable of adapting to various changes. Say, for example, if a customer demand changes with respect to the talk time, that is nothing but the cycle time. So both cycle time and talk time, both the term are the meaning one and the same. It's not a different meaning. So according to the external demand, so we have to fix the cycle time constraint for an assembly line. Say, for example, how to calculate the cycle time. So projected requirement by number of shift to be operated. So the projected requirement is nothing but the expected demand as per the customer, the statement what they have formulated. And based on that, so we want to realign the assembly line sequence in order to operate all the production task according to the changing the fluctuation in the customer demand. What are the main important objectives of line balancing problem? The first one is minimizing the number of workstation. So by reducing the number of workstation, so we can able to maximize the line balancing efficiency. The next one, minimizing the cycle time. With the lesser time, we can able to speed up all the assembly line, the task activities as earlier as possible. And finally, we can able to improve the workload smoothness, that is line efficiency. And we can also maximize the total, the throughput efficiency of the work. What are the basic steps carried out in assembly line balancing problem? So there are two different circumstances in assembly line balancing problem. One is arranging the job activity number as per the precedence constraint. Every product cannot progress to other next assembly line station if it does not complete the necessary task in that particular station. It should not across other station because certain parts need to be performed in the specific assembly line. So without that, we cannot bypass the task number to the next neighborhood of assembly line station. So every task has to be executed in an orderly manner without violating the precedence relationship. That we will see in the case study with the diagrammatic illustrative concept, U-type assembly line balancing problem following the precedence constraint matrix. Next one, cycle time restriction. Cycle time is a maximum time for the product spent in every assembly line workstation. Okay, the maximum time allotted for performing the different activities that are helpful to complete the final assembly of the product. Say, for example, if an assembly has 20 parts, to connect all the 20 parts into a final complete assembly, what is the time spent for doing that? So it is a cycle time constraint. So these are the two limitations based on which the line balancing concept can be operated much efficiently. And now coming to the basic, the procedure in solving the line balancing problem. There are four different stages in line balancing problem. So first one is construction of a precedence diagram. The precedence diagram is a logical layout of an assembly line which can demonstrate the relationship between every workstation. A certain process begins when the previous process was done. Determining the cycle time. The cycle time is nothing but the longest process time that can be allowed at each workstation. This can be expressed by using the following formula. The cycle time is equal to available time by desired output. This means the product has to leave the station before it reaches the cycle time. Calculating the efficiency of line. This is done to find out the maximum line efficiency. The formula is given by sum of the task time divided by number of workstation into desired cycle time. So these are the four basic stages that are calculated, that are followed in line balancing problem. What are the different techniques, ideas that are used for solving the line balancing? To take a computational method of line balancing problem using software packages, there are two algorithms. One is incremental utilization heuristic, the other one is longest task time heuristic. So using these two algorithms, we can efficiently solve the line balancing problem. So what is the difference between these two ideas? In incremental utilization heuristics, the task numbers are added to each assembly workstation without violating the precedence constraint. So every task numbers are added one at a time. So the maximum, the percentage utilization is 100% in every workstation. Next idea, longest task time heuristics. So it assigns the job number to every workstation without violating the task precedence, at the same time without violating the cycle time constraint. So this is the difference between the two number of techniques, two different techniques in line balancing problem. Now let us have a small case study for U-type assembly line balancing, say PCB electronic manufacturing assembly line. So in the following table, which describes about the number of activities, activity description, activity element timings, and the supporting activity we call as a predecessor. So these are the table information which is given here for your reference. And the description of the U-type assembly line layout. So here I can explain what is meant by a precedence constraint. See the task number 1, task number 2, 3, 4, 5, 6. So each and every task numbers are scheduled as per the sequential order. So without changing the job order sequence. So this is one of the challenge in the assembly line. So the above figure that clearly explain the list of activities that are involved in the PCB assembly line process that has been scheduled as per the precedence network constraint as shown above. And also the cycle time which was said to be 15 minutes. How? So from the previous the element timing, the table, the maximum cycle time, the longest process, the timing, the task time from the table matrix is said to be 13 minutes. So I have just incremented by applying incremental task heuristic method. So I have just maximized the cycle time from 13 to 15 minutes. So workstation formation of assembly line. So after fixing the cycle time, based on the cycle time, number of precedence matrix and the individual process time of the every job number, based on which we need to construct the different assembly line cell or workstations in order to group the activity into the work cell. So here, when the cycle time is 15 minutes, say for example, if I'm grouping activity 1 and 2 in assembly line 1, so what is the total, the station time? So 6 plus 3, 9 minutes. So that is my station time for grouping 1 and 2. And idle time, so cycle time minus station time. So 15 minus 9, 6 minutes is the remaining idle time continue to occur in assembly station number 1. Likewise, for other 6 remaining assembly stations, you have to compute station time and idle time successively as given here. And this is the formula equation for finding out what is the result for station time and idle time. For one particular task example, for grouping of task 1 and 2 alone, I have shown here how it comes. The task, that is station time and the idle time for the activity 1 and 2. Next one, finding out the overall line balancing efficiency. So sum of all process timing of an activity by number of station into cycle time. If you want to convert into 100, multiply by the percentage efficiency 100. So the sum of all task time is said to be 76 minutes. How we are getting this number? So add all the station time, work element timing, so that you will project this value divided by number of assembly station into cycle time. So you will get 72.38% the line balancing efficiency. Thus, the line balancing efficiency for the U-type assembly line is evaluated depending on the number of workstation and cycle time respectively. So the outcome from this case study, so it has been the case, an attempt has been made to solve the U-type assembly line balancing problem for an electronic PCB manufacturing method with the help of incremental heuristic algorithm method. So the line efficiency was proven to be 72.38%, which is considered to be moderate average in nature. The maximum idle time assembly, there are 3 assembly stations at which the maximum idle time is generated. So as workstation 1, 4 and 7. So due to that, it gives a medium moderate percentage yield regarding the balancing efficiency of the assembly line. And what is the conclusion about the idea, the concept? So at the overall, line balancing is said to be a production technique which is used to smoothen the workload constraint for the given cycle time. The main idea of line balancing concept is to adjust the station workload as per the cycle time constraint. The line balancing helps to maximize the line efficiency by assigning the workload in the assembly station. So in this case study, attempt has been made to solve the line balancing problem under U-type model configuration for the PCB manufacturing application. So the U-type assembly line balancing is illustrated with the precedence array diagram with the process timing for various task elements. So in the case study description, various workstation, you say various workstation along with the station timing and idle time was discussed in the illustrative case study with the help of the precedence graph. In addition to that, the line balancing efficiency is computed as per the cycle time limitation. So with this, I thank every one of you for listening towards the lecture on line balancing concept. So these are the references, journal articles which I have referred for my work. So thank you one and all.